As I welcome you all here, we're going to take a quick look at the agenda because I do want to share the wonderful folks on this committee that have put this meeting together. I'm Ann Murphy, the president of the League of Women Voters of Spokane. And Amy Compostine, whom you see spotlighted here, is the chair of this committee and has most elegantly shepherded this group along. Our moderator for the evening will be Constance Holland, and we'll have the things to share with you. Other members of our team are, who's coming up next here, Amy? I've got Rebecca McMullen, Pamela Joyner, who recently joined the team, and Rebecca McMullen, who led us last year in considering sustainability action plan, and we'll look at how we can keep moving forward with that to fit in with this piece. And who else do we have, Amy? Elaine Harger.
We also have Stevie Watson, but she is not able to. I'm not able to spotlight her.
And Babs Velategui, who has been on our team but had to take a break this year, so we're glad she's back here for this presentation. And at this point, we will introduce our other speakers when we get to those points in the agenda. And at this point, I will turn the meeting over to Elaine Harger for our land acknowledgement.
Elaine, you're muted.
We acknowledge that we live on land stolen from the Spokane people, land central to their culture, health, and well-being. Today, we must also acknowledge that our current way of life steals healthful land and air and water from future peoples. We must act upon these truths and take actions that will create restorative justice for all people and the earth. We are the ones we have been waiting for. The time has come to act on what we know.
Good evening. We are very excited tonight to share with you our topic of regenerative agriculture. Last fall, two of our team members, Stephanie Watson and myself, attended the Food and Farm Expo, where we heard Ray Archuleta, who you will see in the film clip tonight, and tonight's speaker, Scott Gale. Their presentations were exciting for many reasons, not least because we and the LWV of the Spokane area members live in one of the most productive agricultural areas of Washington and the nation. And also because the main biological response to the impact of greenhouse gases has been to plant trees, which can take 10 to 30 years before they are effective in sequestering carbon. But the impacts of regenerative agriculture can be seen within 2 to 3 growing seasons. Regenerative agriculture has impacts far beyond sequestering carbon that include mitigation of soil degradation, erosion, drought, and it can increase the nutrients in food without chemical inputs, all while reducing the cost of agricultural inputs and offering potential increase in farm profits. Tonight's program will also include the role of home and garden composting in addressing some of these same environmental problems. Next slide. To give you some idea of how significant the loss of our soil is, scientists have found that approximately 35% of the US Corn Belt, also once called our breadbasket, has lost its most fertile soil, topsoil, since the 1800s. This has resulted in annual economic losses of about 2.8 billion and a 6% reduction in crop yields per year. Dust storms like those seen here and during the Dust Bowl are increasing in frequency. Next slide.
It is Scott Gale talking.
Today, the agricultural the agrochemical industry, with profits projected to amount to $14.08 billion this year, claims that organic agriculture can never be anything more than a niche product, and that the world's food needs can only be met with the widespread use of insecticides, herbicides, fungicides, and fertilizers. But you're about to see the consequences of that widespread use and hear how others not only disagree with the agrochemical industry, but are making a success of farming without it. And we'll now start our film.
I am a conservation agronomist. We get the soil right, we can fix a lot of our issues. Healthy soils lead to a healthy plant, healthy animal, healthy human, healthy water, healthy climate. This is what this is about today. Learning how the soil works and learning how to farm like nature does.
The message is simple, but getting that message out is difficult.
We have a social problem. We have an education issue. And until we get that right, we can't fix our ecological issues. I have been in NRCS for 31 years. It was kind of amazing to me as I was teaching all over the country. I'm going, wow, our producers don't really know how the soil works. They don't understand the basic ecological principles. Everything runs by carbon. We're built by carbon. The soil microbes run by carbon. Carbon is the driving engine. It runs the system.
But when it comes to the role of carbon in our world, there's a bit of confusion.
What is carbon dioxide?
It's comes from.
That's a trick question for me. You caught me off guard on that.
I guess that would be carbon and two molecules of whatever.
Something bad?
It's poison that you're breathing, and it will destroy you.
To be specific, carbon dioxide is a gas. We breathe it out, and plants breathe it in. We also make carbon dioxide by burning fossil fuels. But carbon isn't bad. In fact, it's the basis for all life on Earth.
There's a tendency right now for us to be at war with carbon. Carbon's the bad guy, and I think this is a lost opportunity. Carbon's the good guy. We're carbon. I'm 16% carbon, and all of it came from eating vegetation and things that eat vegetation.
Plants use sunlight as energy, and they pull carbon dioxide out of the atmosphere. They turn it into a carbon fuel, and that's how they grow. But 40% of that carbon fuel, they send down to their roots. They're leaking it out in a very strategic way to soil microorganisms. Plants are feeding soil microorganisms carbon, and the soil microorganisms are bringing plants mineral nutrients. And in the process of all that, those soil microorganisms make a carbon glue out of that carbon fuel. And they make habitat in the soil. They make little pockets in the soil to control the flow of air and water. And that's one of the ways that carbon gets fixed in the soil.
In other words, soil has the unique ability to sequester carbon dioxide out of the atmosphere. That's a big deal. And what's even more amazing, the soil contains an entire universe of life.
Here I went to years of college, and I took soil science. I didn't know. I really did not know how the soil worked. It's alive.
In every handful of healthy soil, there are more organisms than the number of people who've ever lived on planet Earth.
I believe in miracles. Where you from? You sexy thing, you.
And those organisms are processing organic matter that's in the soil and putting the nutrients into a form that the plant needs. Comparing the soil microbial diversity to the microbial diversity that we're now seeing inside the human organism. You have more bacterial cells in your body than you have human cells.
Yeah, we're about 1% human and 99% microbes. It's the truth.
The food that we eat, we actually chew and break that food material down into little bits that get eaten by the bacteria in our gut. When you eat kale, let's say, when you're eating kale, your body doesn't consume kale. The bacteria consume the kale. And you feed off of what the bacteria have processed and released by the consumption of that kale.
The key to health is eating dirt. What I mean by that is we need to eat what's in the dirt that's transferred to the plants that then we eat and create health.
Taking care of the microbes in the soil is critical for human health. But spraying the soil with toxic chemicals, well, does something else.
All of our soils that are under chemical conventional agriculture are almost completely devoid of microorganisms.
Spraying the soil with toxic chemicals kills the very microbes we need to give us health and pull the carbon from the atmosphere. The more tilling that's done, the weaker the soil gets, and the more farmers feel compelled to use chemical sprays. This is the vicious cycle of industrial agriculture.
It takes more nitrogen now to raise a bushel of grain than it did in 1960.
Our chemical fertilizers mask the problem of degraded soils. Modern agriculture was not designed for the betterment of the soil.
Today, our most common crops are genetically altered to resist the spraying of toxic pesticides. For example, the #1 crop in the United States, field corn, is almost entirely sprayed with glyphosate, a chemical suspected to cause cancer that's so oversprayed, it's found its way into our drinking water.
These chemicals, which were considered dangerous to begin with, are now being used at rates that would have been inconceivable 20 years ago.
Every year, for every American alive, 3 pounds of toxic chemicals are sprayed onto the food grown on our farms.
That goes into the soil, it goes into the water, it goes into our bodies. It's not just on the food you eat, it's everywhere.
Most of the agricultural industry's pesticides and herbicides transfer directly through breast milk to babies. There are over 200 peer-reviewed studies that correlate the spraying of these toxic chemicals to effects like ADD in children, pediatric cancers, and birth defects. That's why juries have begun to award billions of dollars in damages to people who contracted cancer after using glyphosate.
We know, for example, that glyphosate, which is also known as Roundup, has an effect on the gut microbiome that may lead to disturbances that can create disease, including cancer.
A big reason these chemicals make us sick is because just as toxic chemicals kill the microbes in the soil, they also kill the microbes in our bodies.
What I tell people is your body can handle acute stresses, but it cannot handle chronic stresses. Soil ecosystems the same way. If you keep dumping the fungicides, you keep dumping the herbicides, you keep dumping the insecticides, you keep doing the tillage, chronic stress, it doesn't function anymore.
Since chemical agriculture ramped up worldwide in the 1970s, we have lost 1/3 of the Earth's topsoil. But industrial agriculture isn't just harming our soils, it's also affecting something much larger.
The most massive tsunami, perfect storm is bearing down upon us. But fossil fuels, carbon, coal, and gas, are by no means the only thing that is causing climate change. Now, because the fate of water and carbon are tied to soil organic matter, when we damage soils, you give off carbon. Carbon goes back to the atmosphere.
Healthy soils absorb water and carbon dioxide. But when we destroy soil, it releases water and carbon dioxide. This dries out the soil and turns it into dust. The process is called desertification. And how we deal with it could determine the fate of more than just our climate.
Desertification is a fancy word for land that is turning to desert. And this happens only when we create too much bare ground.
Soil and the plant and the climate are connected. If you don't have a living plant, you're going to have more evaporation. What we want is transpiration. When the moisture leaves through the plant, when it does that, it increases humidity, and when it increases the humidity, we have more rain. 60% of our rainfall comes from the ocean. But a lot of people don't realize 40% comes from small water cycles where our rain comes from inland. What's going on is we disrupted the small water cycles. That's when you have too much sensible heat coming off bare soil. You're having these huge vortexes of hot air going out. Instead of attracting the rain, it's pushing the rain clouds away.
Take 1 square meter of soil and make it bare, and I promise you, you will find it much colder at dawn and much hotter at midday than that same piece of ground if it's just covered with plant litter. You have changed the microclimate. Now, by the time you are doing that on more than half the world's land, you are changing macroclimate.
According to the United Nations, the world's remaining topsoil will be gone within 60 years. In other words, unless we find a way to save our soils, we have 60 harvests left.
Next clip. I am pleased to have the opportunity tonight to introduce Scott Gale of the Spokane Conservation District. As biomanager, Scott has spent the last 4 years working with a group of like-minded farmers to find ways to work with nature and restore the soil's resiliency in our area. The BioFarm Group believes it is their duty to work with nature to ensure the future of farming, the health of our food, and that the next generation of farmers will be able to stay on the land. Scott, we are so glad to have you here tonight. The floor or the screen is now yours.
All right. I unmuted myself. See if we can pull this off. Share. Let's try this again. Okay. All right, let me change the, let me know if you see one or, yeah, one screen or two.
One.
Looks good.
Perfect. All right, ladies, sit down, strap in, and hang on, because this is going to be baptism by fire. We got some work to do. Hang on, let me grab this thing over here, because that's going to drive me nuts, and put it right there. All right, everybody can hear me okay? Yep, all right. My name's Scott Gale, and I work for the Spokane Conservation Group. We have a biofarming work group we started 4 years ago. And what was happening was when the bad farmers fail, no one cares, like when they have crop failures. But what was happening is a lot of the really good farmers were having some pretty big crop failures on pretty large scale. So we wanted to get away from mainstream agriculture, and it was just figure out, let's form a group, like-minded individuals searching for a, oh, come on, hang on, sorry. I got to move this thing out of the way. It's right on. Right there. Searching for new path to productivity, profitability. And our original goal, just so everybody knows, is our original goal was just how in the heck can we cut 50% of the chemical use out of our system? I mean, we are cheap, fast, and easy got us where we are today. American food, US food policy. Our food policy is really a weapon of war. And that cheap, fast, and easy got us where we are, and it's not going to get us out. We said, and we meet on a very regular basis. We ask a lot of questions. And so we started out with what's organic matter and carbon, and why is carbon important? Provides nature's ecosystem services. It's critical for the soil functions and quality. It's a building blocks almost everything, and it's how Mother Nature stores energy. And I do a lot of talks, and I've converted all my talks now to energy and calories. Energy in, energy out, calories in, calories out. Every time a plant has to stop to buffer something, buffer the bad, it cannot grow a good crop, and it can't grow yield. So we had to feed the good, feed the microbes, feed the plants. And as Christine Jones said, or Hyman said, we're 16% carbon. It's pretty important. How much money could possibly be involved in this? The estimate of ecosystem services in North America alone is $10 trillion. There's a lot of players at this table right now with the whole new carbon thing. And a lot of it's relatively shady. There's way too much big industry involved. But we got to start somewhere. So let's unpack a few problems first. You heard Ray talk about water cycles. 60% of the rain comes from the ocean. That's our large water cycle. 40% from transpiration, plants and trees, and that's our short or small water cycle. I hear it all the time. Thanks, Ray. I hear it all the time. We'll come back to this a little bit later. Do we really have a precipitation problem in the PNW? So I go to events all over the country. And you'll hear, and people from here go to these events, and they'll Minnesota, Iowa, pick a spot. It doesn't matter. Oh, they get all this water. Oh, they get all this water, and we don't. Deal with it. That's our deal. So do we really have a precipitation problem? No, we don't. I don't have a precipitation problem. We have a drought every year. I know every year that my water's turning off in June. I don't have to wonder. I grew up in a dairy farm in central Minnesota. If the water turns off in June in central Minnesota, you have a real big problem. Not a kind of problem, a real big problem. We don't have that. We have an infiltration problem. How do I know that? Because we lose 4 tons of topsoil per acre per year. It's called T loss, and it's one of the most just things that tick me off that 7 ways from Sunday. So what do we got to do? We have to have soil water holding capacity. We have to be able to get the water in. What good is it if we can't hold on to it? We have to tie it to soil organic matter. 1% soil organic matter holds 25,000 gallons of water, 2% 50,000, 6% holds 150,000. Most of our P&W ag soils are less than 2%. Almost all the soil organic matter tests I see are less than 2%. So if I could hold 150,000 gallons, how does that affect our small water cycle? And how does that affect our rain cycle? It's unbelievable how much it does. If we don't cover our soil, what happens? We lose by wind erosion. Wind erosion, honestly, in our neck of the woods is a bigger deal than water erosion. 4 tons of topsoil an acre per year. Here's an interesting one. They had that question, or you had a picture on your first deal. Does anybody have any idea where this is? This isn't in Saudi Arabia. This isn't in the Middle East. This isn't in Texas. This is Ritzville, Washington. That was taken out the back door of one of my best friends in Ritzville, Washington 2 years ago. What in the world can we do about it? So we have a problem. We have to have some solutions, or at least be working towards it. So we've got like-minded people with a purpose, with a plan. They can steward the soil. I use this word steward all the time now, and I take it very seriously. It's in the Bible, stewarding the soil was one of the most, being a steward is one of the most important things you can be. And we have to rebuild that soil. And how do we rebuild it? With efficiency and resiliency. We've got to build that back in. It takes 4 times the amount of nitrogen to grow a bushel of wheat in 2020 as it did in 1960. Chris Nichols talked about that. We average a 20% nutrient use efficiency with our fertilizers on a good day, going downhill with the wind in our back. And that's with our fertilizers and our application methods. It's a combination package. So how do we do it? We take principles and we turn them into a plan. We got to start with microorganisms. The key to this whole deal is microorganisms. The problem is we've been killing everything for the last 50 years, ever since Butts told us to go farm fence row to fence row. That was a real good idea. There are more microorganisms in one handful of soil than all humans on Earth ever. Go think about that one for a minute. That's staggering. I can grow 1,000 pounds of yeast in 24 hours. 1,000 pounds of yeast is 42% protein, so I have 420 pounds of protein, and that's 67 pounds of nitrogen I grew in 24 hours under the absolute right conditions. And I don't know what the number is, but it'd be 2 to the 10 to the 10th power of the amount of microbes that you could grow in just 24 hours. Plants and microorganisms build soil. But you also don't lose fact that we're growing crops. We're still growing crops for people. It's not as simple as saying, hey, Mother Nature did this, let's go do that. We learn those principles, but we're still pushing crops through this system. So if plants and microorganisms build soil, there must be something to it. What do we do next? We got to have some new tools and new strategies. And I think Ray said in that deal, and Archuleta was here last fall, and we spent a lot of time together, and he's a pretty funny guy, and he's now an honorary member of my group, and he's coming back out this summer to do a field day in June with us. And he said it's the gray matter. It's that it's that 8 inches between the ears that everybody has the hardest part changing on. So we got to utilize so first we got to know what we're working with. So we have new testing methods. I'm going to rip through this pretty hard because a lot of it you'll understand why, but so we do different labs. So what do we have in our soil? If you have it, can you use it? We do respiration rate tests. So this tells us how many microbes we have in the ground and then how much food we have for those microbes. If it's in the soil, is it in our food? And we're going to wrap back around. That's bottom line. If it's in the soil, is it in our food? That statement is in our food is literally consuming my entire life. Here's just a copy of a Donnell test. I deal with a gajillion of these. The top part tells you what's there. The middle part tells you what's available. The bottom tells us how to fix it on paper. Then we go to apical ag plant sap analysis. Well, it's a real-time snapshot of what's going on in your plant. We know how minerals translocate through plants. So we literally suck the sap out of the top part of the plant and the bottom part of the plant. And we know how nutrients move through a plant. So we compare the old with the new. We evaluate toxicities and deficiencies. Louise, you're writing on my screen. write a recommendation, apply mainly through foliar apps. And this is if it's in the plant, is it in our food? What are the micronutrient levels we need for a healthy plant in nutrient dense food? And we're going to wrap back around to that one pretty hard. Here's just a copy of, this is a canola trial I did 2 years ago. And the main thing to look at is look at all the yellow. This is grower control. This is standard grower practice. This is what I did. And all I did was change the way I buffered off the bad, fed the good with organic acids. And organic acid is just complex sugar, microbial derived complex sugars. And so we buffered off all the bad stuff. And now we have a plant that functioned at a much higher level. So there was a lot less to fix. It was easier and cheaper to fix it. Why do we go to all this trouble? And ladies, I cannot describe to you how many hours I have. I have no concept of a 40-hour work week. This is everything I ever do. And why do we do it? So we can work with the plant to give it what it wants, when it wants it. So let's take a look at, I moved the winter wheat. Don't worry about that winter wheat slide, I moved it. All right, here's a little bit, I guess I didn't move it. We have to understand when the plant needs the nutrients. And I'm going to unpack this real fast. This is just a growing stage graph of wheat. And we know that if we don't get certain nutrients at certain times into that plant, it greatly affects yield. And I want to unpack something real quick. There is no such thing as going from conventional to organic in a growing season. It does not happen. It will not happen. It cannot happen. I have personally tried it and given it the old college try as good as you possibly can, and we failed miserably. And we spent a trainload of money to try to pull it off. Now, can we do it in a couple of years? Absolutely. But this is what the nutrients the crop needs during a growing season. This just is different, is a little quicker thing, and we have to understand how much it needs. So what does it need and how much does it need at very specific times? So if you look at this graph on the bottom left is October. When we grow winter wheat in the PNW, most all of the fertilizer is put in the ground in September and October. And now if we look at that line by 0, that's how much nitrogen that plant needs in October. It doesn't need any. It doesn't need any until you get over here to March, and really into April is when it really gets hopping. That's when it needs it. We do it because logistically we have to. It makes perfect logistical sense. It makes terrible agronomic sense, but when you're farming on razor thin margins, you do what you have to do logistically. And as you all know, finding help, good labor is almost impossible. So I came up with something a couple of years ago called the Great Reset, the BHAG. You have to have a big, hairy, audacious goal. I think that's a Zig Ziglar saying. Or you got to start some big, foolish project like Noah. That's my other favorite one. So I took a 40-acre field that was solid weeds. This is the worst field I've ever farmed in my entire life. I messed around with it a few years ago, and it had been so conventionally and chemically farmed, I couldn't get legumes to grow in this. I put 10 bajillion, 10 to the 10th power of legume seeds in there and would have one every 20 steps. So I left it for a couple of years, and the landowner wanted me to do something. And I told him, if you're going to let me do what I want to do and anything I want to do, I'll take it over. So we did. I've now turned it into a research farm. Tillage is bad. I'm not going to disagree with that. I run no-till programs. I'm going to tell you right now, I tilled this thing to the end of time, and there's a reason. I had to get rid of compaction, aluminum, and herbicide layers. If the plants start out at such a negative, I don't have a fighting chance. So I did 2 passes with that big subsoiler in the picture. I cultivated it to level out, harrowed it to level, and then I came in and injected 10 gallons per acre of microbes and organic acids, and once again, organic acids, complex sugars. And then we planted a living root in it ASAP. We don't have enough time for this next video, so I'm going to rip through it, or I'll let it play for a second maybe, but this is a subsoiler. Pass 2 of the subsoil. We did 20 degrees off south. First pass. Now we're doing a straight north-south line. Because the shanks are too far apart, we need to move. So, and I'll just get off of that, but just to know the amount of dollars spent on equipment, there was probably $400,000 right there when I was sitting there talking. that was being used. Here is low system. What are you doing? Hang on. All right, let's do that. This is the planting drill and little tractor I use for my plot stuff. It's a 10-foot drill with a liquid injection system. Back to our winter wheat. Usually when you see winter wheat in conventional farms, you pull it out of the ground and there's nothing stuck to the roots. There's a whole pile of stuff stuck to those roots because I planted it with a gallon of organic acids and microbes, 2 gallons of 721,4-OA. We're not going to talk, that's conventional fertilizer that I complexed. I took really good, clean, food-grade fertilizer, complexed it with organic acids because I need the phos and I need to grow the plants. Once again, I'm still in a food system. I'm growing crops, but I can buffer off the bad, complex it, and make it really good, and then use way lower rates because my nutrient use efficiency goes from 20% to 80%. We also seed treated it with 60 different strains of biology, and then we're going to foliar feed it this spring. Starting, well, I would say April 1st, but it snowed. So we're going to start next Monday. It's a very odd year. What about planting something different besides winter wheat? This is chicken mix. This is my favorite slide in the universe. This is my favorite idea I've had in the last 5 years. What the heck is chicken mix? Well, what if we took trit, DNS, and barley on one row, peas, flax, and canola on another row? We developed it as a cover crop to be a cash crop. For a producer who doesn't want cattle, we combine it all together, send it in to get a feed analysis, and then we use it as a base blend for animal rations. Now all of a sudden my cover crop becomes a cash crop. I have got more mileage out of this idea. One of my buddies is the smartest guy I know in agriculture, period. With the stroke of a pen, he can move California agriculture. Even he said, you know, you come up with some wild crap from time to time, but this is about as good as it gets, buddy. Look at what it did to the weeds. Weeds are on the left, that dog fennel, chicken mix on the right after it's dry. This is last year in a drought with no rain. The weeds stopped dead in their tracks. It's interesting because we can control them without herbicide. We had some planter operator rain problems on the left, and we basically stopped the weeds at the border. And it's not, we didn't spray the crop at all. I had people from WSU and University of Idaho in there trying to figure out, how did you do this without spraying it? Nature will do it. This is the only green crop in the PNW on June 29th. This is a different cover crop that was planted with microbes, organic acids, and just a tiny bit of fertilizer. A 3-way blend, no rain. We were going to graze it, but we just ran out of time. So we roller crimped it. I'm going to run this for about 20 seconds. This tool is going to change the PNW. So we use that tool to roll down cover crops. And this next one is we rolled those cover crops down. And then if you can see growing there, there's rows of winter peas and then rows of winter canola. If we can get this figured out in the PNW, this is a big deal. On a winter canola, we grow train loads of spring canola, but it's 3x the yield on the winter canola. Same way, we took all the conventional fertilizer out of the system, and we're doing it a completely different way. It takes a village. You can't do this crap by yourself. Here's a $500,000 combine with a $100,000 header. With a $100,000 header. Change it, you got to do something different. Absolutely. And what do you do is different? You got to grow roots. And then we have some herding herbivores. I'm running short on time. I'm going to go through this pretty quick. Livestock. I'm going to make my next shirt is going to be livestock, and only livestock will save the world. Period. End of story. There is no question about it. Yep, they poop. There's methane, cow farts. God and nature figured this out a long time ago through photooxidation. Transpiration, we photooxidize with hydroxyl and bicarbonates. With the methane, we turn into CO2 and water. Once again, 65 million buffalo, 130 million antelope, 2 million wolves, 2 billion prairie dogs had this stuff figured out a hell of a long time ago. This is new strategies in just fertilizing on applying different types of fertilizer and just the amount of machinery involved in what we do. This guy farms 15,000 acres. You do it with real big stuff. Is it working? We research and develop an idea, design trials, put them in the ground. Last 4 years, our group spent over 200,000 of our own money. Some fail miserably. Some clog your sprayer, smell really bad, and elicit quite a vocabulary. You haven't lived until you've been covered with enzymatically digested fish. I just want all of you to know that. Oh my God. You just throw the clothes away. That's all you do. Oops, there's my thing. But some light up a new path. And I'm going to start it there, and I can keep going, but we'll do some questions. So there's 26 members in 2 groups that I run. We personally own or lease / control 150,000 acres, and I directly influence about 400,000 acres. The one thing I do want to get through in this real quickly is this one slide right here. How can you help? This is what I want to know. I can spend all the time. I watched the quarterback the other day for the NFL sign a $230 million contract to throw a football. Who cares? I spend all my time trying to grow nutrient-dense food so we can have great health. Every time we shop, we vote with our dollar. Are you going to buy it local, or are you going to order it online on Amazon? You can order it online, but should you? What will it take for you to spend more money on food than on healthcare? In the 70s, 16% of our money was spent on food, 8% on healthcare. Today, 8% is spent on food and 16% is spent on healthcare. We have a problem. And I'll end it with this one, because this is one of the best sayings ever done. We do not have a health crisis in this country. We have a nutrition crisis. If we take care of the nutrition problem, the health problem will take care of itself. That was from Bruce Tyneo. So I will field all questions you guys have, and I hope you enjoyed the presentation. I work for the Spokane Conservation District, and I'm pretty easy to get a hold of, not this time of year, as I raced back here, because I got a new phone and it erased my calendar. So we'll open it up from there.
Okay, Scott, I'm Elaine. I've been monitoring the chat for questions, and we have a few of them that have come up. Can you hear me okay?
Yep, I can hear you fine.
Okay, excellent. So one person wanted to know where your research field is, and can people visit it?
So it's yes, and it's Madison. It's down by Valley Ford, off of Gibbs and Madison. It's what's that, west? If you go west on Gibbs, it's the first field on the left, the first farm field on the left. It's fenced in. There's a horse trailer there, and it's pretty easy to find Gibbs and Madison. We're gonna have a field day out there in June with Ray Archuleta, so that'll be available.
Wow. Well, you're going to have to let us know so we can let all of our league people know when field day is.
Absolutely.
Okay. Another question is, what is a live root?
So a living root, the only way to get carbon into the ground is stuff it in with a living root. So a plant exudate is the most important thing in the universe. Photosynthesis is the most important thing. Ray Archuleta said something in there about farmers don't understand how the soil and the plant systems work. We've forced farmers to become logistics people. We've forced them to become mechanics. We've forced all these things on them. And what we forgot to do was continue to how to grow a plant. Very few farmers can explain to me how basic photosynthesis, and I'm not saying that as a knock on them at all. I don't have a clue how you fix a combine. But we've specialized so much, we've taken a lot of that growing stuff away from the farmer. So a live root is how so I have to grow something all the time, or I'm going to try to grow something all the time. And the reason is because I got to take free solar energy through a plant into a form of a root exudate. And that root exudate puts carbon in the ground and feeds microbes. And those microbes sit and etch away all the other stuff we need. So instead of having to spray it on and spray it on and spray it on, we can get those microbes to work for us. Now, the hard part is we're trying to figure out there's a give and take with everything, right? So we're just going to use 120 bushel winter wheat. If I can grow 120 bushel winter wheat today, how much can I grow if I use microbes and organic fertilizers, for lack of a better term? Can I grow 120 bushel wheat? Can I grow 60 bushel winter wheat? Can I grow 200 bushel wheat? I don't know, but there's a tremendous amount. I think right now, we have a train load of acres in trials right now, well north of 1,000. So the living root is how we're going to get to the next level. So all this wheat fallow stuff you see in Washington that was given to us by WSU and all the academia, quite possibly the worst thing ever put forth on a farmer.
Okay, let's see. Another question that's just come up. A lot of times people talk about how bad livestock is for the planet because they produce so much methane. Can you explain why the animals are actually our friends in this problem?
Methane, God and nature figured this out a long time ago. Has anybody ever read Undaunted Courage, Lewis and Clark, the Lewis and Clark journals, any of that? They were, obviously they had to be because that was their job, but they just kept these amazing journals. And I have all the Lewis and Clark journals. And they talk about grass over the top of a horse's back and buffalo from horizon to horizon. And I've spent a lot of time in the Dakotas, and I've stood on many hills and wonder what does it look like to see a buffalo from horizon to horizon and grass over a horse's back, because it's not that today. And the beauty of the Lewis and Clark journals is because of Google Earth and all these other things, we can go see where it is. But anyway, cow poops on the ground or buffalo. The blue is transpiration from water. We have to have water. Why do I want to infiltrate water? So I can have a small water cycle. When the methane, when that goes up, the transpiration, the water photooxidizes and breaks apart into hydroxyl and bicarbonate. The methane comes up from the cow poops, and then the hydroxyls and the bicarbonates attach to that methane, and they break it down to CO2 and water. So they complete the cycle. Well, everybody says, oh, CO2 is bad. No, it's not. CO2 is not bad at all. We can't live without CO2. We are dead tomorrow without CO2. The problem is we have all this CO2 in places that we don't need it. I'll give you all day long that 100,000 cow feedlot's about the worst thing you can have in the universe. But if I have those cows outside on grass, pooping and giving me CO2 and water right underneath these plants, I have to have carbon dioxide to break apart in order to form. The first stage of photosynthesis is splitting water, and then I fuel that. I need the carbon. That's where all of our carbon that they talked about comes from CO2. So I don't know if I just answered your question, but the cycle, it's a cycle. And here's the problem. Academia and all the BS of the world and everybody's platform, they work in this linear fashion. Nature doesn't work linear. Nature's a whole. It brings it all around. I mean, I tell you what, it's really important to get back to the whole, and everything we do is about getting back to the whole. And cows/buffalo, there was 65 million buffalo here for a reason. For a reason. Don't ever forget that. We just have to get back to doing this a whole heck of a lot smarter than we have, and get away from modern food policy, Department of Ag food policy. So anyway.
Okay.
I hope that answered your question.
Well, I understood it. So we have one last question, because we're going to have to move on to our other parts of the program. But do you have any advice for home gardeners who have to deal things like invasive knotweed? I mean, you had your research field where you got rid of all of that, all of the weeds that were growing there. What would you say to backyard gardeners about how we can contribute to growing good soil?
So I, long time ago, used to work for Living Water, and I was the main diagnostics guy for Living Water. And at that time, this was a long time ago, they had 4,500 households. So when there was a problem, I was the guy that showed up. I spent 90% of my time turning people's water off. It is absolutely absurd, the amount of water we put on our lawns in this town. It is incredible. I ran an organic lawn care thing for a while after that. And you can, as long as you deep water, as in go put a bunch of tuna cans out in your yard and see how much water you're actually getting. If you get a 1/2 inch, and I used to have all these little sticker things, 1/2 inch to 1 inch of water per water, and you only have to water twice a week, and I don't care how hot it gets. Overwatering and over application of fertilizer is one of the worst things you can do. The next worst thing you can do is put weed and feed on your lawn. There's probably more horrible chemistry in weed and feed. It's the biggest load of crap ever sold to you because it has to stay on the leaf in order for it to do it. So as soon as the sprinklers hit it, most of the time it blows it right off of there. Find some chicken-based, what's his name? Vern, Strawberry Hill Nutrition Farm. Everybody should write this down. Go see Vern at Strawberry Hill Nutrition Farm. He sells Perfect Blend. There is no better fertilizer in the unit. Fertilize your own yard with Perfect Blend, 10 pounds per 1,000 square feet, 3 times a year. You can do it 4 if you want to. We'll grow grass like you can't even comprehend. As far as the gardening goes, nature does mulch. Trees mulch. Nature eats from the bottom up. It doesn't, nature, we love this cute green, this wonderful, nice cultivated dirt. It's horrible. Take grass clippings, take leaves, take whatever, make a mulch out of it and cover up your garden. Good. And split it and grow everything as a transplant. In a garden, you can do it. You can pull it apart and seed like carrots and little small things like that, but grow it as transplants and use drip irrigation, Netafin drip irrigation. Super easy. It'll be way better. It'll fertilize itself, the worms, and then inoculate the damn thing with some wheat. Go buy some worms at the store and dump a dozen worms in the thing and let them go to town. You knock it out of the park or dig some out of your deal. So,
all right. Sounds like a party in the raised beds.
Yes.
Okay. Well, Scott, thank you so much for all this information. I mean, it was really wonderful. And so I'm going to turn this over to—
Hey, Elaine, just one thing. Let me move. I don't know if you can see this. Yes. Can you see this thing here? Walter Yenny, Director of Healthy Soils Australia.
Yes.
So everybody should go to YouTube and type in Walter Yenny, Harvard. And he did a talk at Harvard, it's like 2 years ago. And it's like soil carbon sponge, and everyone, it's a 2-hour talk, and everyone on the planet should be forced to watch this, and you will love it. He'll go through this whole thing right here. This is all his work. And he's the main climate guy from Australia. He's the one that came up with it and has been studying it for eons. But everybody, please go look at Walter Yenny on YouTube.
Okay, will do. We'll add it to our resource list.
Well, thank you guys for having me. I really appreciate it.
And make sure we get that resource, the Strawberry Hill thing too.
Yep.
Perfect blend fertilizer from Strawberry Hill Nutrition Farm, Vern Fulstrom.
Strawberry Hill Nutrition Farm is out in Green Bluff, for those of you who don't know. It's like one of the first ones as you drive up the hill into Green Bluff. But we'll make sure we add that to our list. Scott, thanks again so much. Really, I enjoyed meeting you, and I was so excited last fall after talking to Ray, and all of a sudden here's this guy from Spokane who's talking about the same stuff, and that was really exciting to have. So I'm glad we got the chance to have you here.
Well, thank you very much, ladies. Have a great evening.
You too.
Bye.
Okay, if I could get the next slide, Amy. Thanks. Remember how I told you earlier that the agrochemical industry says we can't feed the world without added chemical inputs? Well, this picture is a very good response to that. In the US, this is how much food we're wasting annually. For many nations, the problem isn't a lack of food, it is a poor distribution system. In the US, 30.63 million tons of food ends up in landfills or waste incineration like ours. In 2017, This resulted in a release of 14.1% of the human-caused methane emissions for the US. Carbon dioxide emissions were also increased through the handling and the transport, moving this waste out to landfills or to incinerators. But it doesn't have to be the case. Anne, would you like to introduce our next speaker?
Absolutely. So Amy, I need that slide. And we are going to expand on what Scott was just talking about in terms of what you can do in your own backyard. Our master composter recycler, Laren Sunday, is joining us. I first met Laren when she took the class I was responsible for teaching way back when, Laren. And so we're going to learn some things that you can do in your own backyard. And I am going to now, hopefully, there we go, pull up Laren's presentation and we'll get going on what you can do. So Laren, you have the floor.
Well, thank you. I have to say, I was at the Farm and Food Symposium in November. I actually presented for the Spokane solid waste composting. I was so energized and I left feeling so positive that there were farmers trying to make corrections to what we've been doing to this land for decades. And I really am pumped that Scott was here. If you can see the rest of Kiss the Ground, it's awesome. So let's go ahead and start about composting. Go ahead to next. So we've already gone over this, waste reduction, 1/3 of all household waste can be composted. Anything we can do to keep what's on our property that we generate in our kitchen or our yards in our yards is going to save us fuel, time, and money. I live in the country. I don't have a green bin. Anything I have to get rid of, I either compost or I have to haul it into town, or sadly, I have to burn it. And I don't want to do that. Composting is a great way. Once you have completed compost, it improves your soil structure, its composition, its water retention, which if we continue to have summers like we've had the last few, water retention will be key. Compost allows the soil to maintain its water longer, which means that your plants have more time to absorb that water and not get water stressed. So if you have poor soil, sandy soil, clay soil, you always want to add compost and or organic matter. It isn't a high nutrient amendment, but it has a low, even distribution. And it also helps maintain soil temperature, which again is going to be key in the future. Next. So we heard a little bit about what actually makes our soils work, and it's the bacteria in the soils. There are literally thousands of species of bacteria that live in the soil, and each of them have a very specific purpose. Next slide, please. The other main microorganism in the soil is fungi, and yeasts, molds, mushrooms are our most typical fungi. If you see that slide on the bottom left, all that white is actually a fungal growth that occurs on woody tissues as it decomposes. Those fungi like those hard to digest materials. Oh, we're losing something. There we go. And the fungi actually bind soil particles together. It's estimated that there are 3 to 10 yards of fungal hyphae or filaments in a teaspoon of soil. And that number to me is mind-boggling. I don't even understand how that's possible. But those are the microorganisms that allow our plants to feed. They send out chemicals that attract the fungi and the bacteria. They allow the plant roots to absorb nutrients. It's an exquisite dance between all the microorganisms and the plant roots. So next slide, please. So if you've decided that you want to make a difference and use what's in your yard to feed what's in your yard, you want to think about building a compost pile. One of the first things people go is, well, where am I going to put it? Do I have enough room? Where, how do I function? So location is not that big a deal. It needs to go on bare ground. It can be in sun or shade. The most important thing is access. After dinner, do I really want to go to the back 40? For me, I have acreage. So do I want to go to the back 40 and take all those scraps from my salad out to the compost pile? No, I want something a little closer. I want to be sure I can get a wheelbarrow or cart in there. I do chip, which means I put all of my waste, yard waste, through a chipper to get a more even particle size. And I want to make sure that wherever I put my compost pile, I have access to water, because that's one of the key components to building a compost pile. I want to make it 3 by 3 by 3 and no bigger than 5 by 5 by 5, because I'm only 5 feet tall. So I don't want a compost pile staring me in the face. It's just too hard to work unless you live way out in the country and have your own little machinery to take care of it. In the backyard, the 3 by 3 by 3 is perfect. Next slide, please, Anne.
It should be there.
There we go. Okay. So your basic recipe for compost at home is 2 parts of brown, which is a carbon source. And on the left, you see pine needles. Another big option is shredded paper, shredded leaves from the fall, those ornamental grasses that brown out in the fall. Those all make great carbon sources. So 2 parts, and then 1 part of green. And green is basically your kitchen scraps. You're going for a 30-to-1 carbon to nitrogen, but for a lot, I love math, so it doesn't bother me, but we don't have enough time tonight to go into all of that. But if you just go like 2 bucket loads of carbon and 1 bucket load of nitrogen, you're going to be fine. You're going to mix them up so you have air. You're going to add water till it's as wet as a wrung out sponge. And you're just going to keep building the pile and adding material. Next, please. This is just a little bit more information on typical browns and greens. So when you think of a brown, it's a high carbon, think wood chips, dry to the touch, something you would maybe access in the fall, your pine needle straw, paper, wood chips, sunflower stalks. Nitrogen is usually a little bit wetter. Sometimes it's green in color. One thing, coffee grounds and tea bags are a nitrogen source. Even though they're brown, they're still high in nitrogen. Your fresh leaves and your grass clippings. And if you're going to add grass clippings, be sure you don't use weed and feed on your lawn. And if you do, leave the grass clippings on the lawn for anywhere, depending upon how safe you want to be, 3 to 10 mowings. Next slide, please. There is an online calculator that you can use at clickitat.county.org/solid waste. And you can actually input the materials that you have, and it will provide a ratio or a recipe for how you mix that with what you have. So next slide, please. So I've called this controversies. It's actually more like, well, what do I do? So one of the questions we get a lot on is eggshells. Do they compost? Do I really want them in my compost pile? Do they attract critters? So eggshells really don't decompose. They just get into smaller and smaller and smaller pieces. On the good side, think of them like the good side of plastic. If you put a plastic bag out there, it will decompose into 10 million little pieces of plastic. Eggshells do the same thing, but they're good. The sharp edges, after about a year, 6 months to a year, there are no sharp edges. My purist vegan friends do not, of course, have eggshells, so they don't even want eggshells in their compost. Personal preference, I love them. I go ahead and scatter it on my beds, and I get a lot of birds coming in the spring. They seem to want that calcium from the eggshells. So to me, it's a win-win. Manures, most of us don't have access to manures, so I don't think it's a big issue. If you do manures, you want to make sure you have manure from an animal that's an herbivore. Think sheep, goats, alpaca, cows, rabbits, chickens, even though they're an omnivore because they do eat bugs. Chicken manure is excellent. If anybody offers you horse manure, I'd say no, because of the persistent herbicides that are still allowed for farmers and ranchers to use on their hay fields. They don't use it in the hay themselves, but they use it on the edges of their property to keep the weeds from coming into their hay fields. So typically, I don't recommend horse manure. We've discussed coffee grounds in brief. I have another purist. He doesn't like the chemicals that are used in the processing of coffee grounds, but I think it's a great way to take that source of nitrogen, get it out of the waste stream, and go ahead and use it in our gardens. You do not want to use it strictly on the top of your grounds, your beds, because it does inhibit the flow of water, but you can compost it very easily. Citrus. Worms don't like citrus, so if you do a worm bin, definitely do not add it. They do decompose slowly, but I have tons of citrus in my compost piles and I have never had a problem, and I always have lots of worms. Pine needles, big controversy, big misunderstanding. Pine needles don't decompose and they acidify the soil. Well, yes, they do decompose. Otherwise, we would be 30 feet deep in pine needles in Spokane County, and we're not. They don't acidify the soil on the long term for about maybe a week to 3 weeks. After they start decomposing, they will slightly decrease the pH of the soil. But Spokane has pH of about 7, which is neutral. So pine needles are great. They just have to be chopped up through a shredder or a lawnmower. You can just mow them. And then I did have somebody who wanted to add mushroom compost and chicken manure and topsoil and all kinds of different additives to their compost pile. It's not necessary. And I kind of like to think of it as, what do I want to spend my money on? Do I want to buy something that I don't know where it's from, that's been shipped, that has a plastic bag, and then add it to my compost pile when I'm trying to benefit the earth? To me, it's a no. It's not necessary. It doesn't improve the compost at all. Next slide, thank you. So what to leave out? No cat, dog, or pig manures. We could get sick from the compost that is made from those additives, those ingredients, because Typically, we don't get our compost piles hot enough. So no disease plants either, anything with something really nasty, fire blight, apple scab, that needs to go in your clean green or in your trash. Any weeds with mature seed heads, anything, if you don't like it in your garden, like quack grass, for me, it's vinca, morning glory, bindweed, anything like that, put it in your clean green or put it in the trash. Your grass clippings, 4 to 6 mowings at least if you use a weed and feed, which I highly discourage. No meat, fish bones, anything that is from that's not a vegetable or a fruit product. And even though food, soil, cardboard, paper plates and napkins and all that meat and fish can go in your clean green, again, most of us, if we're going to try to do composting in our backyards, we're not going to get the heat needed to get those things decomposed. Next slide. And we're going to attract nasty critters. I shred and chip my material because I have acreage and I have a lot. And I like to put everything through the shredder at once. If you have a lawn, you kind of have a built-in shredder with your lawnmower, unless you do a push mower. But a lot of your stuff can be shredded a little bit. And anything you can do to increase the surface area on your particles that go into the compost pile is going to speed the decomposition. Next slide, please. This is just a demonstration of the pile building that we do at Finch Arboretum. And in case you're interested, we are having an in-person compost fair on Saturday, April 30th, between 11 and 2. Again, Finch Arboretum. And there'll be a real live active compost pile there that will be hot, which means it'll probably be anywhere from 150 to 160 degrees. And if it's this flipping cold then, as it is now, it will be steaming visibly. Next slide, please. So we want as much moisture as a wrung out sponge. If you have too little moisture, the bacteria and the fungi that live there don't have enough moisture to live off of. Just like us, they need water to survive. If you have too much water, the bacteria that live there change and they go from what's called anaerobic, those who like oxygen, to anaerobic. And anaerobic bacteria cause those horrible smells that you get from solid grass piles, decomposing bodies, you know, that cadaver, putrid smelling stuff. So next slide. So make sure your moisture is adequate, but not too much. And that's just some of the problems you can have if you don't do it to the formula. But they're easily fixed if you just add whatever is needed. If you have too much moisture, you add brown. If you have too much green, you add brown. If it's just sitting there not doing anything, you add more green. Okay, the compost fair. And can you?
Hey, well, what happened to your slide? I'm seeing the slides, but that sounds like you're not.
Okay. Okay,
I've
there
got
it goes.
uninvited guests here.
Okay, can you go to the next one?
Yep.
So if you don't bury your food scraps, you may have mice, rats, squirrels, raccoons, skunks. How long does it take? It depends upon how well the pile was made and if the formula was, the recipe was followed. And again, it can be easily fixed, but you're looking at anywhere from 6 to 12 weeks if you actively turn it every week or so. If you don't want to turn it, It's okay. It's called passive composting. And I have several piles in my property that I do passively and I don't turn them. If you live in a condo or apartment or don't have the capability to make a compost pile outside, bokashi is an option for you. It is not a composting, it is a fermentation process. We could do a whole hour just on bokashi. So I'm just going to mention it. There is information online for that. And the next slide is vermicomposting, which is using worms, red wigglers, typically, to take your kitchen scraps and turn them into, it's called castings. It's basically worm poop, which is excellent compost additive for your gardens. And that's composting in like 8.3 seconds. Oh, so I don't know if you all know this, but in the state of Washington, it is now legal. When you die, you can be composted instead of buried or cremated.
Oh my, thank you so much, Lauren. This was excellent. I'm Elaine. I've been trying to monitor the chat for questions. And we have just a couple minutes before our next presenter.
Can you see that?
It is not in front of your camera. Otherwise, oh yes, now we can. Saturday, 11 to 2 at the John Fitch Arboretum Compost Fair. We'll make sure we get that information out to all the league members.
And the reminder there, you're still giving away a bin, aren't you, Lauren?
Yes, we are. For any
you come
resident
and go through the fair and you get a bin to take home so you can compost.
We have one quick question. Can you put cooked food like, refried beans and macaroni in there?
It can go in your clean green bin if you have access to that. It should not go into your home composting system or your worm bin. It can go in your bokashi bin if you decide to do bokashi.
Okay, and the reason for that is because there's often dairy in it and oils.
Mm-hmm. And a lot of those food products attract more critters than normal. Pasta, breads, they seem to attract the things that you don't want because we all like our sugars and our carbs.
Okay, well, thank you so much. We're going to be moving on to the final part of our program. It's been wonderful hearing from you, Lauren.
Thank you.
Thanks, Lauren.
Hello, I'm Rebecca McMullen. I'm part of the Environmental Issues Committee, and we wanted to share with you, in addition to reducing and composting your food waste, we wanted to share another way that you can take action to reduce your household's impact on the environment. As league supporters, we know that we need to advance policies that support sustainability across many sectors, along with technological solutions, but we also need to be supporting individual behavior changes and cultural shifts. So there's a new sustainability initiative supported by Spokane City Council, this website, sustainablespokane.org. It's a sustainability challenge website. It's a new program, so you all have the opportunity to be early adopters and leaders in this initiative. And for those who live outside of the city of Spokane, there is a similar site that is for the entire, well, it's around the whole country, but there's a Northeast Washington site. So I'm just going to put in the chat 2 links. That first one, sustainablespokane.org, is the challenge for the city of Spokane. And then the second one, Bright Action, is the platform that has the site all around the country for free. And then you'll be in a Northeast Washington region. So we can go to the next slide. I just did screenshots so that we would go through faster and you wouldn't have to watch me load a website. So this is how it works. You join the challenge by creating an account and completing a household profile. Then you select actions you will take, or you can indicate ones that you've already taken to make your household more sustainable. And you can also create a team or a community group and work together with your neighbors, your coworkers, your faith community, share your experiences with taking these actions, encourage each other. And if you want to, you certainly can explore the actions on the site, the opportunities and knowledge that's on there before you create your own account and profile. You can do it that way. So if we go to the next slide, you can see this is the home screen for that Northeast Washington site. So if you're in Spokane Valley or elsewhere outside of the city, this is the site that you can do. And it's the same functionality, it just isn't connected to the city, so it won't have resources. So there's an action for being water wise and installing a low flow toilet. So if you're on the city site, you'll see that there's a rebate if there is still, whereas the bigger regional site won't have those city specific opportunities included. We can go to the next slide. And the main purpose of this challenge is to learn about and take household actions that will reduce your impact on the environment. So, and often save money. So you can search by category and filter through dozens of actions. So since we've been doing agriculture and composting, if we click on that one on the right, the Eat Green, Waste Less category of actions, we can go to the next slide. And then you'll see under Eat Green, Waste Less, there are many actions in that category. You can indicate ones that you've already done. So this is from my account. I had previously started to buy local and buy organic. So that just kind of gets checked off my box, but I only get points for the new things that I do. So if I choose to skip the packaging, then I'll get points because I've started to reduce the packaging I'm purchasing at the store. So we can go to the next slide. So to get the most accurate assessment of your household's impact and your progress, you would need to complete the household profile. And that bar at the top shows you the types, the categories in this profile, the questions it'll ask. So it'll say how many people live in your household. So it'll take your whole household emissions and divide that by the number of people. Or for appliances, it will ask you if you have a gas dryer or an electric dryer. Transportation, it'll ask you how many cars you drive and how far do you drive them and how often do you fly on an airplane, that type of thing. So the calculator and data behind this site is extremely robust and accurate for these categories. So you get a pretty good idea of what your real impact is on these household activities, transportation, your food, your heating and cooling of your home, those types of things that are included. It's very accurate. So if we go to the next slide, once you have your household profile, then you have your own dashboard. This is from my account. And on the left side, you can see the navigation bar. I could jump to my region. I can look at actions. I could, you can see that I'm earning points and getting fun badges. And it's showing me my progress as I'm taking new actions. I'm saving some money and I'm reducing my emissions per year. It also keeps track of water savings. If you'd have to scroll down this page to see some more information on that. And if I wanted to start a team with my book club, I could click up on the top line there to join or start a team. And if I had a bigger group, if I wanted to have my whole faith community of 40 households, I might want to use the community group function, which is for a larger group of people or group of households. And then we can go to the next slide. So on the left, that's how you create an account. You need an email, you create a password, you can name your household. So we're the Mad Max, but you can name your household whatever you like. And then on the right side, I also shot this of how you can explore the actions. So there are whole categories of actions that are renter friendly, or ones that are really easy, quick and easy. And all these actions have information on them. So you can learn about vampire load. When you leave things plugged in, a little bit of electricity is being drawn by that plug, for example. Small actions can add up to a lot of savings, both for your household and for the planet. Or you can choose to do a big action if you're highly motivated and excited to dive in. So I'd be happy to answer any questions about the new program. And if you're really interested in helping to promote this new Sustainable Spokane program, the challenge, there is a meeting tomorrow from 2:30 till 3:30 with the website, the people who run the website, to learn about how to do community engagement to really launch this challenge in around the city.
Oh, thank you so much, Rebecca. There weren't any questions, so I'll turn it back over to Constance.
Okay. Well, I want to thank everyone for joining us tonight, and especially to thank our speakers for their important and exciting information that they've shared. Please note there is a link we've added for how you get to the additional resources. We've put together a list of resources, which includes how you can view the entire film, Kiss the Ground. We are going to, and if you want to wait until tomorrow to look at that link, we're going to add we'll add these sources that were given to us by our speakers. So we'll get it all the way up to date. And so you know where you can go to get some of those things as well. Thank you all. This has been something the environmental group has been very excited about, and we loved having the chance to share it with you. And now I'll turn it back to Anne to talk about what's coming next.
Thank you, Constance, and thank you to this entire committee. And Amy's got one last slide here for us that, oh my gosh, we still have a lot to do yet this spring. So these dates have all been in the voter, and so you can quickly scan down what dates are there. And at this point, I'm saying thank you again to our entire committee, Amy taking off, leaping into being the chair, and then Constance with the fun ideas that got pulled together for this program tonight. And so we appreciate that. And with that, we can officially adjourn unless anyone has any other questions. If you would like to linger and chat, we'll toss it back to gallery view, and so that you can all come together and have any questions before you wind up leaving. Any comments or questions, you can type them in the chat or raise your hand and we can visit, or we can say goodbye to you as well. So whichever you want to do, no pressure.